Here are the solutions for some of the questions on the page 34 review problems. I'm not going to work out all the solutions because you do have a printed answer key available to you. Number 1 asks you to specify by roster, and it describes the set of living ex-presidents. At the time the video is recorded, the living ex-presidents are Carter, Bush, Clinton, then George W. Bush, and Obama. The next one I'm going to work out an answer to is number 5. True or false? Every set has at least 2 subsets. That is false, because there is one set that doesn't have 2 subsets, and that is the empty set. The empty set has only the empty set as a subset. Next, number 7. Is this statement true or false? 9 plus 3 is 12, and 12 divided by 3 makes 4. Now the right side, 12 plus 4 is 16, and 16 divided by 4 is 4. The statement is 4 is not equal to 4. That's false. Number 8, is the set containing multiples of 5 a subset of the even integers? To be a subset of the even integers, every element in this set must be an even integer. So let's consider some of the multiples of 5. 5 times 1 is 5, 5 times 2 is 10, then 15, and so on. Are all of these numbers even integers? The answer is no, so this is false. Now jump to number 25. We're asked to graph this inequality. X is less than or equal to -1. Locate -1, give it a closed dot because of the or equal to portion, and then shade to the right because of the greater than symbol. Number 26. N is in between -2 and +4. So here's -2, to the right, +4. This gets an open dot because no equals to bar, but the 4 gets a closed dot. And then shade all the values in between there. Number 27. Shade everything that is not equal to -1 and it's not equal to 3. Well, here's -1 and here's 3. We want it not be equal to -1, so an open dot. And not be equal to 3, so an open dot. Let's shade everything else. We're shading over all the numbers that are not -1 and they are not 3. Number 28. Shade S equals 0 or S equals 2. Well, here's 0 and here's 2. Put a closed dot on 0 and a closed dot on 2. Beginning with number 29, we're asked if this set of numbers is closed under addition and under multiplication. To be closed under addition means if you add any 2 of the elements together, you get an element that is in the set. For example, if you add the 0 plus 0, you get 0, which is in the set. Or if you added the 0 plus 1, you get 1, which is in the set. However, if you add 1 plus 1, you get 2, which is not in this set. And so the answer to question A is no. Now question B, what about with multiplication? 0 times 0 is 0, which is in the set. 0 times 1 is 0, that's in the set. And 1 times 1 is 1, which is in the set. So this is yes. This set of numbers is closed under multiplication. The next several questions ask the same thing. So number 30, if we add these fractions, do we get an answer that's in the set? No, we don't. Consider adding 1/2 plus 1/2. That makes 1, and the number 1 is not in that set. What about multiplication? 1/2 times 1/2 makes 1/4. That is in the set. 1/2 times 1/3 makes 1/6. Following the pattern given by the dot, 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 that would be in the set. So this is yes. Number 31, let's check addition. -2 add -2 makes -4. That's not in that set. We know the answer is no. Let's check multiplying. -2 times -2 makes +4. That's not in the set. The answer is no. Number 32. Let's check the addition. -1 plus -1 is -2. That's in there. -1 plus -2 makes -3. That's in there. It looks like this answer is going to be yes. Now let's try multiply. -1 times -1 makes +1, which is not in that set of numbers. The answer is no. Jumping to number 44, we're asked to solve an equation, then graph the answer on the number line. For this equation to turn out to equal 0, this expression must turn out to equal 2, because 2 plus -2 makes 0. So we know that the absolute value of -x has to equal 2. What could x be? Well, x could be 2 or -2. Substitute those in there and mentally check the answer. If x is a 2, then inside the bars is -2, and when you do the absolute value bars, you get 2. If x is -2, then inside the bars is the negative of -2, which is 2, and the absolute value again is 2. To graph this, find -2 and +2 and put dots on both numbers. Now number 45, solve for a. Let's simplify the right side. So this is equivalent to 1 over a equals -2/5. 1 over a is how you show the reciprocal of a. So the reciprocal of what number is -2/5? When you flip that fraction upside down, you get -5/2. To graph that, you locate -5/2 and put a dot on it. Another way to solve this equation for a is to recognize that it's a proportion, and it can be solved using cross multiplication. One diagonal is a times -2, which is -2a. And that's equal to the other diagonal, 1 times 5, which is 5. Then divide both sides by -2 to solve for a. Now number 46. Let's solve for s, which appears here in the bars and here on the right side of the equation. For number 46, the answer is empty set, because we can find no number for s that will work. Whatever number we try to use for s, when we evaluate that absolute value expression, we then add -4 to it, which will definitely turn out to be a different answer than what we've used for s. Because the answer is empty set, there's nothing to shade on the line. Now number 47. This time the answer is t is greater than or equal to 0. Let's check that by substitution. If t was 0, then -0 is 0, and the absolute value of 0 is 0. 0 equals 0. If t is a positive number such as 1, then inside the bars we have -1. The absolute value of -1 is +1, so 1 equals 1. However, t cannot be a negative number. For example, t cannot be -2, because this expression with the absolute value bars will never turn out to be a negative number. To graph this result, locate 0, put a closed dot on it, and shade to the right. Now number 48. This time the answer is r equals 0, because 0 is the only number that will work. R cannot be any other number, because then the left side of the expression will turn out to be a negative number, and this expression on the right will never be negative. So r equals 0 is a dot at 0. Now number 49. This expression must turn out to be 1, because 3 plus 1 would make 4. So we know that -k has to be a 1. Therefore, k is -1. That's a dot at -1. Number 50. The absolute value of n is greater than 2. An absolute value with a greater than symbol can be rewritten as a compound inequality. Here's how you do it. The expression in the bars could be less than the negative of the 2, or the expression in the bars could be greater than the 2. To graph that, locate -2 and 2, open dots on both, shade everything less than -2, and shade everything greater than +2. For number 52, we're asked to provide the reasons and a proof of this statement. If m equals n, and r equals s, and r is not 0, and s is not 0, then this equation is true. Statement A. Why are these real numbers? That information is given in the textbook. Statement B. Why do we know r is not 0 and s is not 0? That's given in the beginning part of the sentence. Statement C. How come if we divide m by r, n by r, and n by s, we know that those would make real numbers? That is the closure property of division. If m is a real number, and you divide by r, which is a real number, you will get a real number. Statement D. Why is it okay to write m equals n? That's given in the first part of the sentence. Statement E. Why can we write m divided by r equals n divided by r? What has happened to create that equation from the equation written right before? Do you notice both sides have been divided by r? That's the division property of equality. Statement F. Why can we write r equals s? That's given to us in the beginning part of the sentence. Statement G. Why can we write n divided by r equals n divided by s? That's the division property again. Because we had just said that r was equal to s, then this is an example of an equation where both sides have been divided by equal things. Finally, statement H. Why can we write m divided by r equals n divided by s? We'll take a look at this statement from earlier and this statement from earlier. If n divided by r is equal to n divided by s, then the n divided by s can be substituted for n divided by r. That's the substitution property. Number 53 is another proof. Here's our sentence, and here are statements, and in the column for reasons, I've left 2 of them blank. Statement 3. Where does this equation come from based on what was written just before? Notice that both sides are multiplied by -1. So this is the multiplication property of equality. Statement 5. Where does this equation come from based on what was written before? In statement 4, we have the equation x equals y, and in statement 5, what was added to x was -k, and what was added to y was -t. What property justifies adding equal things to both sides of an equation? That's the addition property of equality. The next problem that I'm working out an answer to in the video is number 56. This question asks if the set of negative integers is closed under subtraction. Let's try some subtractions with negative integers to see if we get a negative integer. -1 subtract -1 makes 0, which is not a negative integer. So this is no, the set is not closed under subtraction. What about the set that contains positive and negative integers? Let's try some subtractions. -1 subtract 3 is -4. That's in the set. How about -1 subtract -1? That makes 0, which is not a positive or negative integer. It's not in the set, And so the answer to the question is no, it's not closed under subtraction. Beginning at number 58, we have several adding and subtracting problems involving positive and negative numbers. Remember that there are two adding rules. One rule has to do with adding numbers that have the same signs. The other rule is about adding numbers with different signs. For any problem that is a subtraction problem, the technique is to change it to an adding problem so you can decide what rule to use. Number 58, negative 7 add positive 2. The first number is negative, the second number is positive. They have different signs. Find the difference of their absolute values. 7 minus 2 is 5. And give the answer the sign from the number that has the greater absolute value. That'd be this one, which is negative. So the answer is negative 5. Now the subtraction. Negative 7 add negative 2. This number is negative and this number is negative. They have the same signs. Add their absolute values. 7 plus 2 is 9. And give the answer the same sign as the numbers you were adding. Negative 9. Now number 59. The first number is positive, the second number is negative. They have different signs. Find their difference. 5 subtract 3 is 2. And give it the negative sign because this one had a greater absolute value. Now the subtraction problem. 3 plus 5. That makes 8. Number 60. 4 plus negative 3. That's positive 4 and that's a negative 3. Different signs. So find the difference between 4 and 3. That's 1. 4 has the greater absolute value and it's positive, so the answer is positive. Now the subtraction problem. Rewrite it as 4 plus 3. And that answer is 7. Number 61. This is negative, this is negative. They have the same signs. So add their absolute values. 1 and 6 is 7. Give the answer the same sign as the numbers you were adding. Now the subtraction problem. This is equivalent to negative 1 add 6. This is a negative, this is a positive. Find the difference of the numbers. And give it a positive sign because this number has the greater absolute value. Number 62. Negative 4 plus negative 4 is negative 8. Negative 4 subtract negative 4 is 0. You're subtracting the same number as what you had to begin with. Number 63 is the same thing, but more numbers to add together. You might use a calculator to help you do the work quicker. And the answer is negative 1.9. Number 64 has grouping symbols. You do the work in the grouping symbols first. 17 plus negative 3 is 14. The subtraction of negative 22 can be rewritten as adding positive 22. And 14 plus 22 is 36. So this becomes 36 subtract 36, which is 0. Number 65. 21 times negative 14 divided by negative 7. According to the order of operations, multiply and divide have the same level of priority. You do them from left to right. However, if you multiply the 21 times the negative 14 first, you're going to get a very large number that you might not be able to do mentally. It might be better to work in a different order. Let me write the problem like this, and you'll see why it's okay to divide first. By writing the division as a quotient, it's a little easier to see how negative 14 over negative 7 reduces to positive 2. And then 21 times 2 is 42. Number 66. Negative divided by negative is a negative answer because there are an odd number of negative signs. The 196 divided by 49 makes 4, and then the 4 divided by the 7 makes the fraction 4 over 7. For number 67, you do the work in the grouping symbols first. So 3 times 30.5 is 91.5. And then negative 183 divided by 91.5 makes negative 2. For number 68, as you look across the problem, notice that one portion has times 0. That means the final answer is going to be 0. And then number 70. Do the work in the grouping symbols first. 7 subtract 1 is 6. 9 times 6 is 54. 54 add 5 is 59. Everything in the brackets turns out to be 59. 118 divided by 59 is 2.